everybody, this video is about holes of rational functions. I like to think of holes of rational functions like I think of holes in a street. You don't always see them, but that doesn't mean that they're not there. Let me show you an example of a hole using a graph. This is a graph of a function f of x, and notice that if I put in f of 2, I get a value. F of negative 3 also gives me a value, but if I try to put in f of negative 1, it says undefined. This means this function has a hole when the x value is equal to negative 1. Holes occur when we have a common algebraic factor in the numerator and denominator. It looks like this. Say I have f of x is x squared minus 1 over x plus 1. If I factor that into x plus 1 times x minus 1, I can see a common factor of x plus 1. When I set that equal to 0, that says I have a hole at the x value of negative 1. I can rewrite the function as f of x equals x minus 1, but you want to write a note that x can't be equal to negative 1. Our original function f had a domain that did not include the x value of negative 1, so any rewrite of the function should have the same domain. So to find a hole of a rational function, we want to start by factoring the function. From there, you can cross out the common terms, but you also want to take that common factor and set it equal to 0 to find the hole. After that, you can rewrite the function and adjust the domain. Let's look at another example. Say I had x squared plus 3x minus 4 over x squared minus 4x minus 32. I would factor the numerator to get x plus 4 times x minus 1. Then I factor the denominator to get x minus 8 times x plus 4. Because I have a common factor of x plus 4, I'll set it equal to 0. X plus 4 is 0 when x is negative 4, which says there's my hole. I can rewrite my function as f of x is x minus 1 over x minus 8 with a note to say x cannot be equal to negative 4. There are plenty of functions that don't have holes, so if you factor your function and you find that you don't have any common terms, it's perfectly okay to just state that there's not a hole.